Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us here for our latest and final CCNA prep session of the season. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. Before we dive in, I just want to take a brief moment to talk about the CCNA prep program and also cover a few housekeeping items. If you are joining us for the first time, the CCNA prep program provides a series of live sessions that is led by our subject matter experts. We're going to get a chance to explore the latest exam topics, offer opportunities to test your knowledge, and we'll also share some resources to help aid you in the exam studies and also to make sure you succeed in passing it. And speaking of those resources, we do have some activity files for both Cisco Modeling Labs and Packet Tracer, both which can be downloaded at any time in our post-webinar discussion, so you can use for practice at any time. The resource link can be found under Slido in your resources, so please do check it out after the session to access those files. Also, if you're tuning in but have not officially registered for the prep program, I do encourage you to do so by scanning that QR code on your screen. This will ensure that you get access to the resources, and then you also get informed when the session becomes available on demand. Now, I just want to take an opportunity to talk about the Q&A and the quiz questions for the session. This will be an interactive event, so you can participate in our quiz polls. You can also submit your questions, and you can access resource links all via the Slido tool. If you still need to log into Slido, you can scan the QR code on your screen, or you can do so directly through the live streams page. And last but not least, at the end of this event, we are going to be launching a Slido survey, excuse me. And we would really appreciate your feedback about today's session. We always look forward to receiving your valuable comments. All right, so now let's go ahead and dive right in. So we're glad to have our amazing speakers back with us to wrap up season 2. So leading today's session, we have lead content advocate Patrick Argano, and we also have principal engineer Hank Preston. They're going to walk us through today's topic of simplifying SNMP, delivering data for network operation dashboards. Great to see you both. How's it going, guys?
Good. Rigo, you must be wondering why the hat, Hank. What was the reason why you wanted us to wear a hat today?
Well, we're celebrating a little bit, right? We've been doing this for weeks after weeks after weeks, and here we do. We find ourselves at the end of season 2, so I thought we'd spiffy it up a little bit. I grabbed one of my hats. He snagged one as well. Before we get into SNMP, I think I've got an important question that I'm actually curious, and this is one for you, Rigo. Can you explain exactly what the difference between a survey and a poll is? Because you caught yourself and you wanted to make sure that you were clear that it was going to be a survey at the end. I'm just trying to understand like what the distinction between the surveys and the polls are.
Well, we got the poll questions where our audience can participate live during the live stream in one of your amazing questions to help test their knowledge. And then we got the survey at the end that will help us get some feedback about how much our audience loved the session and how much, show appreciation for both of you for presenting this awesome series.
Fantastic. Well, that's good. Well, we do appreciate all the opportunity to hear from all of our attendees here that have been watching us, that are watching us live. So do please participate in that live polling. Send us your questions, answer the details, see how well you know your SNMP along with Patrick and I as we kind of dive through this. It's going to be an exciting.
And if you've been watching, you know that not only do we ask you some specific questions that you'll be able to answer, like multiple choice stuff, but there's that Q&A, right, Hank, where we both keep an eye on it. So if you've got questions about what we're talking about, something not quite clear, that's where you can put those questions in and we'll get you the answers.
Yeah, absolutely. And it's a great way for us to kind of live poll the audience when we've got other questions to go through as well. So definitely have that chat open through Slido so that you can interact with us here live in the session. But it's been great, Rigo. It's any memory highlights, favorite session from the season so far before we dive into SNMP?
Oh man, honestly, each session has been great. It's hard for me to choose one particular session. I would say I loved all of them. They all provide a lot of great value, I think, for our audience here, and they'll continue to provide great value for those that watch these sessions on demand. Yeah, I mean, the whole series has been great so far, and I look forward to working on more with both of you.
Excellent.
Hank, Rigo's answer there is like a dad answer. Like you've got multiple kids, right? Which kid is your favorite kid? You can't talk about stuff like that, right? They're all his favorites. So
I can see that. I definitely have a favorite session from season 2. What about you, Patrick? Do you have a favorite episode from season 2?
I think this one I've really enjoyed putting together the lab, really doing a deep dive on SNMP. I hadn't looked at it in a while, so and then encountering that little issue and connected with our distinguished engineer Joe Clark, and he helped me kind of work through what that problem was. And I'll come back to that later. But I think this is just not because it's the last one, but because I really went all out. And folks, before I ask you, Hank, and I know Hank, it will be DNS. It's always Hank, what's for dinner? DNS. Hank, should we go out tonight? DNS. Right? That's just the answer to it. No, but I really went way beyond the topic. The topic today is SNMP, and the actual exam topic is pretty straightforward. It's just an explain topic, right? Explain the functions of SNMP. So we're going to go way more than that. We're going to explain it a little bit, but then we're going to do some actual demo of configuring it. Did I get that right though, Hank? Is it SNMP? Is it DNS?
DNS is definitely my favorite episode here from the season. I suppose I've let my feelings be known all season long. So yeah, big fan of DNS. But I do agree. This session you've put together, Patrick, is great. When I was doing the trial run for it earlier this week, like it's a definite one. And that idea of going deeper than the actual exam topics, like going beyond explain, has been a theme all season long.
Yeah.
Like most of these services are low level, but hopefully the audience, right? And let us know in chat here in the questions, right? Has this helped you get a deeper understanding of SNMP, of NTP, of some of these protocols, kind of see how they fit? And if you've enjoyed that deeper discussion, like let us know, and we'll keep that in mind for like further episodes.
Yeah, because we could do episodes that are way shorter where we just, target what the exam topic says. Is it an explain or describe? And then that'll be fairly short. It'll be just theoretical. But I think what we've really enjoyed here is showing you these technologies in action, NTP or syslog or network address translation. So it's been fun for us being able to demo that using CML. And we're going to do some cool things today. We're going to go outside of CML as well. We're going to use Wireshark to kind of decrypt some of these packets that are being sent across between devices on our CML topology.
Well, we've got a lot to get to. Rigo, let's activate that first SNMP related poll.
Yep.
And Patrick and I will explore some SNMP action. So we'll see a bit.
Yeah, and folks, just a little heads up, we're going to do things just a bit differently today. Obviously, we're going to do mostly CML config and demonstration, a kind of a lab-driven demonstration. But I thought it was important to just take maybe 5-10 minutes before we get going to just talk about around SNMP, right? Some of the concepts about it, just to make sure everyone's on the same page. There's a lot of terminology, what's the difference between the different versions of SNMP? So I think Hank and I, that's what we're going to look at right now, just for a few minutes. So Hank, I think the first thing that we should talk about is, and I think a lot of people get these confused sometimes, so that's why I wanted to talk about it, is what's the difference between the SNMP manager and the SNMP agent? And maybe folks in the chat can answer that too, can let us know what they think. I've got my own definition, Hank. Do you have an easy one for us?
Yeah, I mean, it is an important aspect because SNMP there's two pieces to it, right? There's something that's generating some information or has some information.
Yep.
And then there's something that wants to collect that information and report upon it. And so I don't have like an easy mnemonic, right? We've talked about some of the fun mnemonics over some of these series that we've had for like OSI layers and the syslog levels, right?
Yes.
This one I don't have, but the way I just kind of have sit into it, right? So the device that's going to be kind of generating all of those things, right? That's the agent.
Yes.
That is where all of the SNMP data, the information that's there. And like any good agent that's out there, you need to make sure that your manager is aware of all of that information, all of the good work you're doing, any problems you might be sending. And so that's probably the best way I have to explain it is like the agent is out there doing a bunch of work.
Yep.
And then it's going to come up with some different ways to make sure that the manager is aware, right? And there's a couple of options on how the manager can get that information, right, Patrick?
Yeah, and James, if you could just share my CML topology, I think an easy way to help people visualize this. So Hank, if I ask, well, I guess it's a bit clear. So on my diagram there at the bottom there, we can see a device that I've named quite originally SNMP NMS. And so this is what Hank's getting at. This is our SNMP manager. This is where we would have a piece of software running. And that piece of software would allow us to well, do some SNMP functions, and we're gonna actually get to those in a second. Ooh, did you like my? Hey, you got it. I wasn't sure you were gonna get my dad joke there. Okay, so yeah, we're gonna get to that in a second. But the SNMP is your network management software or system, and it's a piece of software that will allow you to perform some actions, and we'll get to those in a second. And like Hank was saying, the agent is actually running on the devices that are in your network that you want to gather information from. So in this case, very small topology, we've got a switch and a router. The agent is running. We're going to enable the agent on those two devices so that we can start doing some cool things, either gather some information or generate information from them.
Yeah, and so there's something that we always talk about when we talk about these networked applications, right? There's a term that comes up over and over again, right? There's client server applications.
Yeah.
So question for our chat, the folks that are out there, so drop them in there as we kind of discuss through this. So we've heard that there's an SNMP agent and then there's the SNMP manager. Which one of those is the client and which one is the server? So think about kind of those roles in these network communications and kind of ask yourself, okay, which one of these is actually providing the client function? Which one of these is providing the server function on it? So we'll see if we can get some answers here and on the chat side. But Patrick, how do you think through these client server interactions?
Yeah, so again, I'm thinking of the server as that application that I would install that allows me to either get information from that device or actually push configuration to it, whereas the client would be my device running my agent. That's the way I kind of see it in my head. Is that the way you see it too, or do you see it the other way around?
Yeah, I think that, I mean, that seems like the most intuitive. And my first gut reaction when I thought through this is, oh, okay, well, we see agents, managers, but we always talk client servers, how they go in. And that's where it goes through. I mean, you call it the network management server, the NMS.
Yeah.
But I think when you think through the actual definitions of what a client and what a server are, right? The server is where you're going to connect to get some information. It's where all of the interesting bits of data are. So I think in SNMP's perspective, the agent is actually acting as the server while the manager, right, the NMS acts as the client, because it generally, and we'll turn it around a little bit because there's some other options for kind of some push notifications.
Yeah.
But generally it's reaching out and requesting information from the server, from the agent to pull in that data. So keep that in mind. Like all of these protocols we've talked about, DNS, syslog, they're client server applications. They run over the network. And so maybe take a step back on all of these and just kind of think to yourself, like, which one is the client, which one is the server? Because as we've just seen, like, it may not be as obvious, right? It may not seem as obvious because the words are contextually relevant, right? When we talk about a network, like a network application and client server communications, server in that case means something a little bit different than server in NMS, right?
Yeah.
So it can be a little unexpectedly confusing.
And what's interesting is, and again, if you're building your own network on actual gear and you want to deploy SNMP and start using it, there's loads of companies that make, and I'm just sharing one website here in particular where it's a free piece of software. It's really, really old. It runs on Windows, and it allows you to basically perform SNMP tasks and connect to your devices to gather some information or push configuration, but also receive what we call traps. And we talked a little bit about traps when we talked about syslog, and we're going to come back to that in just a second. So, and just a mention about packet tracer. So I do have a packet tracer activity for this, and the server in packet tracer, if you're familiar with it, if you click on the desktop option of the server and you go through all the different icons, you'll see one is called the MIB browser, MIB browser, Management Information Base. And it's basically doing something similar to what this piece of software is doing as well. So yeah, a bunch of different ways that we can kind of work through these messages that we want to exchange between our devices.
All right, before we jump into this, I've been watching the chat over here. Courtney, great job on that. Switch does equal the client. The server is the NMS. So excellent job on that, kind of pulling those in.
Good.
Is it time, Patrick? Are we going to jump into labs, or we got more to go?
Yeah, I just want to show one last little thing. Well, I do want to talk briefly about the types of SNMP messages or processes that we can trigger. So there's a few. I'm going to focus on maybe the more important ones. So there's a couple of things that we can do. We can do either set actions or get actions from the NMS. In other words, the get is probably the most popular one. We're going to get a piece of information, like what's the iOS version of a router, or what's the interface information, what the routing table, right? We're getting that information. But I mean, I'm also, and was talking to Hank about this earlier, it's also possible to push configuration with SNMP using a set action as well.
Mhm.
And then the two last ones I want to briefly mention is the trap and the inform. They're very similar. These are like unsolicited messages that are sent. And the only difference between a trap and an inform is that the inform is acknowledged. The trap is just sent, and then there you go, you get it. And we're going to use that. And like I said, we talked about traps in syslog. We're going to use that just as a way of seeing SNMP messages between our client and server, as Hank was saying. So just keep that in mind. Keep that in mind as well.
Yeah, and another way we can look at those too is even kind of going back to that manager client or manager agent type of a piece, right? So in a case where, think about, you're at a work, like you're doing some work and your manager walks up to your desk or walks into your office and says, "Hey, can you tell me how things are going with this project that we know you're working on?" Like that's like a get. The manager stopped by and is getting some information. Now, if while they're there, they say, "Hey, I've got this new project I need you to work on." All right. They're providing you, they're setting some new priority that's in place. Now, later on in that day, maybe you're working on that project and some big blocker comes up, right? Power goes out at the site you're supposed to be working on. The fiber digging backhoe like took out a site, whatever it might be. And you want to go make sure that your manager knows about this as soon as possible, right? Exactly. You don't want to wait for them to stop by and ask you. That's where the trap or the inform comes in, where you unsolicited go run down the hallway to your manager's office and say, "Oh my God, I have a problem. You need to know about this," right? That immediate unsolicited message is kind of where those traps and informs come in. Things where waiting the 30 seconds or 5 minutes for the manager to come and ask for it just is too long, right? You need that immediate response.
Yeah, a quick triggered. And speaking of triggered, I think, Rigo, we can bring you back in. If I remember correctly, my first poll question was around, that kind of message. So I'm just wondering if we can have a look at that together and see if people got that one right.
Yeah, absolutely. So so we asked which acknowledged triggered SNMP alert message is generated by an SNMP agent. And from these handful of choices, it looks like our audience did good. Actually, great. Here, we got Trap here with over 80%. What do you guys think of these results?
Yeah, it looks like folks know their SNMP here already a little bit, which is really, really good. I'm happy about that. Like I said, there's a few different types of messages. We're not going to do a big theoretical deep dive here, but those four that I mentioned, and then there's another new one called, newer one called Get Bulk as well, which is popular. But yes, the trap is what we're going to be using a lot today. As we do the lab demo, we're going to trigger. We're going to cause a failure, right? I'm going to do a shut on an interface. That's going to trigger a failure. Obviously, we'll get a syslog message. We talked a lot about syslog, but we're going to trap that. We're going to send an SNMP trap as well, just to see what that message looks like. So, cool. Okay. You can put up the next one as well. And one last thing, Hank, I think before we jump into the demo, and again, I don't want to spend too long on this, but I think it's important to just talk about the versioning with SNMP. We know there's 3 versions. I'm going to put you on the spot. Version 1, version 2, version 3. What are the big differences for you between those ones?
Yeah, I mean, I will say that the biggest difference for me often that goes through is the amount of configuration and complexity sometimes that goes into configuring them. Yes. That's not why we have 3 different versions, right? we didn't create version 3 because it was much too easy to configure version 2 or 2C to be specific. The real reason they were set up was security. It's actually why we've moved and why so many protocols have kind of been evolved over time is unfortunately when we were little internet engineers out there creating protocols and this idea of one system talking to another one, we were a bit naive, right? We figured we could trust everybody. You didn't have to worry about anything.
It's all safe.
Yeah, what's the big deal? And then we very quickly realized that nope, we just can't trust people, right? You just can't trust them out there. Yeah. And so security is often a big push for these. And that's really the big idea here around SNMP version 1, which was completely unsecure, right? Yeah. That was just like telling everybody in the world what you were after. And then version 2C added a little bit of security, not really a lot. But with version 3, right? Version 3, and you mentioned Joe earlier. Joe would be very proud that we're talking about version 3. He's a big fan of the high security SNMP. as a member of the IETF and kind of working on some of those operation protocols that are there. But that's where we truly get what I would consider an actual potential for secure SNMP that goes in. So
yeah. And so what we'll see, we're going to do two demos. I'm going to deploy SNMP version 2C, which is the latest version of version 2, and the C stands for community string. So as Hank was saying, there's a tiny bit of security with version 2. It's almost like a shared password. Basically, we call it a community string. It's a clear text value, but both the agent and the server, or the agent and the NMS, have to have that value configured to be able to authenticate each other. So it's very basic.
Mm-hmm.
With version 3, we're going to see, like Hank was saying, it's a bit more, not necessarily complicated, but there's a few extra steps. We're going to enable a high level of authentication. We'll use stuff like SHA, and a high level of encryption, and we can use things like AES for that. So we're really upping our game with SNMP version 3. And so what I'll do in these two parts, SNMP version 2C, we're going to push that, deploy that on the switch, and SNMP version 3, we're going to deploy that on the router.
Mm-hmm.
There's a lot of commands, folks, and I don't want to do make typos and mess up the lab. So what I'm going to be doing is I'm going to be doing some copy pasting to the CLI. I've got my scripts ready. I'm going to copy it in little pieces so that we can talk through it, but also so you don't have to just kind of wait there as I have to type these commands, because there's quite a few and we don't want to mess them up. So I think we're ready to go with the full demo here, Hank.
Yeah, let's dive in. I'm excited.
We check let's just check that the next question in the Slido as I get my windows all ready here.
All right, so let's bring Rigo back. How are folks doing here on this one?
All right, so let's see here. So the question asked our audience to identify which 3 features were added to SNMP v3 that are not supported in SNMP v2C.
Mm-hmm.
And we got message integrity, we got authentication, and encryption. Those were our top 3 answers in that order. I think our audience did pretty well here too. What do you guys think?
I totally agree, right?
Yeah.
I think that they're there. And the idea behind CCNA prep is this is supposed to be that kind of final polish before you jump out and take your exam. So I think the audience feel proud, feel good, right? You've got some of these fundamentals in place. That doesn't mean stop watching now, right? Continue, stick with us for the rest of the session. But you're doing a great job in this space. I will ask, Patrick, help me, authentication and encryption, those are ones that I think we've talked a little bit about. What is message integrity? What is that all about?
Yeah, that's the classic one, right? So if I send you a message, Hank, I want to make sure that what I wrote and what you get haven't changed, right, en route. So message integrity is basically, it's a hash, right? It's going to use either MD5 or SHA. So it's gonna create a hash value based on this message. So basically, if I send you this bottle in the mail, I'd like you to get this bottle. I don't want you to get this cup, right? So the message changed en route. And so what I'll do is I'm gonna run the bottle through a hashing algorithm. It's gonna give me a hash value. I'm gonna send that to you. You'll calculate that as well, and hopefully you get the same value, meaning that the bottle hasn't changed on the way to you. So. Is that how you see it? I'm just grabbing props that I've got handy on the table here.
I love the off the cuff analogies that we've just been throwing all over the place, but I think you got it, because that's the importance, right? Imagine that a hacker gets in, finds out what your passwords, your keys are, and then they start manipulating the messages as they're flowing through the network. Integrity is to make sure that the message that was sent actually is the message that's
so important. Exactly.
Important in a lot of different security areas. But yeah, that was one of the key aspects. Awesome.
Okay,
all right,
folks, I think we're ready. Let's get that next question ready on the Slido. So here we go. SNMP version 2C. We're going to configure that on the switch. As we've been going on and on about, we're saying, okay, SNMP version 1 and 2, not very secure. We're going to do actually something to help that a little bit. I'm going to paste in here a very simple access list. Now, if you have a look at that, it's basically just permitting one host, 192.168.100.100. And that's the IP address of the SNMP manager, right? The network management system. So what this access list basically is doing is saying, I'm only going to allow that address to do something, right? It's a permit. And we'll see that we're going to bind that access list to a couple of SNMP commands. So pretty straightforward to start us off. These next 3 commands, they're not necessary to SNMP, but in a production network, you would want to use these. And what these commands are, and Hank, I'm sure you've seen those in your own production networks where you're getting SNMP traps or messages, and you want to know where is it coming from, right? So in this case, it's telling me the location of the device. So I put Richardson, which is one of our data centers. Contact information, I just invented an email address. It could be a phone number as well if I wanted to, and a chassis ID information as well. So again, this doesn't make or break SNMP, but it just allows that information to be kind of tagged and added to the SNMP message that is then going to be sent to our manager. Not to put you on the spot, Hank, but are there others that you would use? There's a few more, I think, but are these the most popular ones?
Yeah, those are the ones that I've typically used in the past. I want to make sure that they're head up. The contact is important because so if you've got a large network and you want to know who's important or who should you notify if a problem comes up on here, who's the responsible party, on-site resources, things like that. So that's a useful one to have.
Yeah.
And then chassis IDs to uniquely identify. Although I will say that typically the IP address they come from, and there's other aspects we can have for those, but maybe what you might want to do is, actually, I just remember we've used this in the past to link this back to like an asset tag or some other kind of unique value that we use in our own inventory system to have kind of a hard link between these devices. So these are fields that you can use for whatever might be useful for your own implementation.
And I've configured them here for version 2. When we get to version 3, I'll skip that just because there's so many other commands that we want to focus on. But you kind of get the idea. These apply. The next one is the one where I get to configure the community string, this clear text password that I talked about that the devices have to share. So I used CCNA prep, all uppercase, as the community string. Hank, I think we need to talk about the RO value there, because I think this is something also that's important about SNMP. So there's two options when you configure this community string, either read only, and what's the other one, Hank?
RW, read write.
Yes.
Yeah.
So read only means you'll be able to get information from the device. And so it's kind of protected from someone maybe accidentally pushing a configuration to it, or illegally doing that if it was a hacker, for example. So the other one is read write. It's very powerful. It allows you to do not only get messages, but set messages as well. So setting a parameter, for example. I think, did you have a bit of a funny story about using that on a switch? You were telling me earlier.
Yeah, I mean, at the risk of running out of time for the actual lab that's in here, like SNMP is the protocol that's most often used related to read activities, right? You're trying to retrieve information, statistics, telemetry about your device. Like that's the most common use case for SNMP, but you can actually write and make configuration changes that are there. And practically the only time I've ever had to do this was on a couple of cases where I was trying to configure, take advantage, update a router or a switch that nobody knew what the password was, but we knew what the community strings for SNMP were. And there is a very kind of convoluted process you can walk through to actually update the configuration using SNMP sets if you have the read-write string, where you can actually update it, change the enable passwords, change the telnet password so you can get back in. It's one of those things that when I needed it a couple of times, like you look it up, I actually did it today in preparation, and sure enough, there's still some posts out there you can find, blog posts or post up on Cisco's Learning Network in the community, right? Showing people how to kind of do those activities. Definitely not a common use case, but it is nice to know that it's there if you do need it.
And I think that just highlights how powerful, right? And I mean, I don't want to say dangerous and kind of scare people, but dangerous in the sense that, man, this is in the wrong hands, right? It's like anything in the wrong hands. But yeah, okay.
Well, I mean, just before we go back into it, I think that's the key aspect. Typically, when we configure SNMP on our systems internally, and where I recommend as a network architect, is we usually don't enable read-write at all.
Yeah.
Because you can make configuration changes, and we typically don't want to use SNMP for that.
Yeah.
I don't want to plan for it to be a backdoor way to like break into a switch if I need to. Like that's not a situation I want to find myself in.
No.
Right? I've used it when I've needed it. But when we're actually designing our management and monitoring network, I typically only just do read only with SNMP because that's all I really want to use it for.
And so in this case, in the command there, just to finish it up, so it was read only. So we're just going to get information from that device. And you can see that I've assigned the access list that I just created previously. So that's what I've secured, that it's a community string with that access list. The next command, let's paste that one in as well, is the command that's telling SNMP where to send the traps, right? So these kind of spontaneous messages, where do they go? So I use the SNMP server host command. You can see that it's that 100 address, which is that server at the bottom of my topology. Version, right? We're talking about 2C. And again, what's that community string that I'm assigning to as well? So that's the fundamentals there. There's two more commands that I want to put in place. Now, this one, again, is optional, but it's a really, really good idea, because what happens is that when you initiate SNMP on a router or a switch, it's going to look at all of its interfaces. It's going to assign an index number, and it's just like an integer, like 1, 2, 3, 4. And every time the device reboots, it could assign different numbers to those different interfaces. And those numbers are part of the SNMP packet that's being transmitted. So it's possible with the command that I just put in, that interface index persist command, to persistently use the same value. So it's going to remember what those are. And obviously that's good for you as you're troubleshooting, that you know what those index values are, and they're consistent and persistent, across reloads or reboots or whatever you're doing on your router.
It's not even just for that. I mean, a lot of it's for tracking stats, right? SNMP is often used over very long periods of time. Like, you might have SNMP configured and be able to look back at the trends for the last quarter or even year. And you don't want those index information changing. It can be resolved, but it requires a whole lot of extra effort to map and figure things out.
Yeah.
So having this persistence kind of configured is really important.
And that's just a quick show command showing you what the values SNMP decided to assign. I didn't do this. This was just SNMP decided, okay, that loopback interface is going to have value 7. That VLAN 10 interface is going to have value 8, right? So these are just numbers that it's assigned, and we'll see those numbers in a second when we start generating some traps. You'll see those values appear as well. Listen, one last command before we can actually then start generating a trap is, what kind of trap am I going to want to generate? So again, there's loads and loads and loads of traps that I could generate. I went with something really basic, and I told you what it was going to be. So I'm enabling traps for SNMP for any links going down or links coming up. So in a few seconds, I'm going to do a shut, no shut on a loopback interface on the switch. So that interface is going to go down. It's going to come back up. I should see SNMP generate 2 messages or 2 traps. I'm going to see those locally in a second, because I'm going to turn on a debug command, and then I'm going to also capture them in the PCAP, or the packet capture tool within CML itself. So let's get that going. So I'm going to do debug SNMP packets, and spell that correctly. There we go. Oops, no, don't know how to spell, so I'm just going to do that. There we go. So that's enabled. And let me open this up a little bit. So what I've done is I've split my panes, right? So on the left, I've got my config. On the right, I've got this PCAP, and I just basically got it ready here. It's basically, I'm going to capture messages going across this link between the router and the NMS server, right? Because they're going to that 100 address, which is at the bottom here. So I'm going to capture those. And what I can do with the settings is I can filter those. You can see I've been doing it quite a bit over the last few days, getting ready for this session. So what I want to do is filter this for UDP port. Oh, I think I just gave the answer to the next question. What's the question? Should we, is that the question right now?
It is. Let's check in with Rigo.
Let's pause.
I was trying to grab you, but you brought it up, and it was like, oh, there it is.
Oh no, I gave the answer away.
Yeah.
What do we got here?
Oh, good, guys. Thank you.
Nice.
So the latest poll, we wanted to know which 2 combinations of UDP port and SNMP message are correct. And we do get a good mix of answers in these results. But overall, I think our audience did pretty good. We got 161 get and 162 trap as the 2 top answers. And I'll let you guys walk through the answers a bit more.
Happy with the results here as well, Hank. And again, this is one of those protocols where there's 2 ports, right? That happens quite a bit. DHCP's got a couple of ports. FTP's got a couple of ports. And so this is another one that uses 2 different ports. One for messages, again, depending if you're looking at it from client or server or from agent to manager. One is being used by the manager, and the other one is used by the agent itself.
Yeah. So in this case, like, if we think through that, so port 161 for GET messages are going to be UDP packets that are sent from the SNMP manager, which is the client, towards the SNMP agent, which in that case would be kind of the server and the communication. And then the traps, 162 for traps, are going to be sent from the agent, right, at the manager. And in that direction, it kind of does flip-flop the client server type of a communication. So it's important to kind of think through those communications. Who's the source? Who's the destination? Is often what you're trying to think through.
So I saved that UDP port 162 setting, and I've started the capture. It's now waiting. I've gone back to the loopback interface on the switch. I'm going to do a shut. we've got to be a little patient, right? We're going to get a couple of messages when the loopback interface comes down. And SNMP is going to start waking up slowly here, and I'm going to do a no shut on that interface as well. And it does sometimes take a couple of seconds for the SNMP messages to start triggering. So let's see if we get any luck here from our device.
When I did my test on it, I had a similar type of a case that's there. While we're waiting for them, and you may have to re-trigger them, we got a couple of questions that are in here. So there was a question from Gabriel was interested in what was, again, the purpose of location and contact, right? And so just as a reminder for those, like the location is a way for you to indicate as part of the SNMP message, right? Where is this device located? I've often used it for rack location or which room in a closet, right? If this is a big campus, this is this telecom closet, that's where location can fit in. Yeah. And the contact would typically be the on-site responsible party to use for those ones. So awesome. But it looks like we got some messages in here. Excellent.
Thanks for filling the dead air as we were waiting for stuff to happen. So I did a shut, no shut. I'm expecting 2 packets and there you go. We got 2 packets captured on the right side, and I can see the debug outputs also giving me that information. So it queued a packet. It was a version 2 trap. It's the loopback interface. Remember that interface index value was 7 for the loopback. So there it is. And we can see that it's gone down. And then it queued up another packet, again, a version 2 trap. Again, it's that loopback interface with interface index 7. And the interface has come back up, and it has sent those 2 packets using UDP to the 100/100 address. And have a look at this. If I click on one of these packets, let me just open this up a little bit more since we're focusing on this. So it came from that 192.168.0.2 address to the server. It's an SNMP message, and holy smokes, there appears to be a lot of information in here, right? So we've got layer 1, layer 2, layer 3, layer 4, and here's our SNMP data. It's a version 2 C message, the community string, right? Clear text, so not very secure. Nope. Let's have a look at what the trap looks like. I'm gonna have to click a few arrows here to kind of open this all up. Click that again, and click that again. Oops, sorry, click the wrong thing. Try that again. Click here, scroll down. And then things get a little strange, right, Hank? It's all hex. I have no idea what these mean. Maybe the 7 here is the interface index. I think that one's pretty easy to figure out. And that 24 is this other 24 number that we saw on the left. But I don't see anything else that I can easily read.
Yeah, I was going to say, this is where we get into it. And I can't remember if we talked about it yet, but there's some other terms with SNMP that often come through. There's the concept of the MIB. I think we've mentioned that. And then the OIDs that go through. And you can see some reflections between here. So like if you look over on the underneath in the left pane, you've got lif entry.20.7 equals up, right?
Yes.
And so what those are is that's the message that's being sent as part of this trap. And we can see there's different aspects, and each of those lines that are represented in that debug show up. And you can see the last one there is 20.7.
Yeah.
So it breaks those down in a place. And now this is where we get into what a MIB is. A MIB is kind of the description of what these numbers mean, how we lay data out. If we're going to send a trap about an interface going up or down, right, how is that message supposed to be structured? And it's important that the agent and the manager, right, agree on how those are going to be set up. So when this hex data shows in at the manager's side, it knows what to do with it, right? And that's why the MIB is important. These agreed upon standard definitions. So that's where MIB comes in. And granted, it's just a description of like, what are we going to do? How is this data going to be sent? And so with that in place, like, what is the OIDs? Do we have any examples of OIDs here on the screen, Patrick?
Yeah, we've got those that are captured in CML, but we'll have a look at this in just a second in Wireshark, because it's going to kind of decrypt some of this so we can see what it is. But Hank is spot on there. So what's happening is we can see that 20.7 on the left over here, right, is the same 20.7 here. But it looks like all of these other numbers from here to here have been kind of converted or represent this kind of bit of text here on the left of the packet. Now, if you're trying to figure what this is, you can go to the Cisco website, and I've shared this in the guide itself. And you can go to this tool called the SNMP Object Navigator. And you can have a look at it in 2 ways. You can either look at it and actually enter a value. As you can see, you can enter a value like this, and then it'll give you what that translates to. What I just wanted to take a second, though, is have a look at at the OID object tree itself. And so why people often ask me, what the heck is going on with all these numbers? Why are there so many of them? It's actually a tree. And you kind of go down a branch of that tree. And what's really nice with this browser, if you like, is that you can actually do that. So way at the root of the tree, at the top, if you like, is the ISO. So that's that first number. That was 1. And then after that, we've got 3, which is org. And if I start opening them up, you're going to see some cool things. So .6 would be the next value. If I open that one up a little bit more, we can see internet. So we've got 1.3, .6, .1. And now from here, things get really interesting. I can go to specific companies like Cisco. I can open up the enterprise branch, if you like. Taking a second here, you can see Cisco is in the list. So you understand what I've just done. I've kind of navigated down that branch all the way to Cisco. But another really popular one is this branch here, the management branch. And we're actually going to do some analysis of some of these as we go through the labs here. But you can see, right? I've got OSPF and BGP and interface information and system information. So I mean, just wanted to show that, and I have shared the link in the lab guide itself as well.
Yeah, and I would encourage everybody. We unfortunately don't have time today to kind of go super in depth in here, but SNMP often can feel very confusing because of these very numbers that are not intuitive to understand what they are. Like nobody knows what 1.3.6.1.2.1.2.1.2.7 is, right? But that actually means something. And that is back to a little bit of that legacy of kind of how the protocols were in place and standards. Like those numbers are indexes. They do mean things. You could take that value, put it into the translate tool on the Cisco site, and it would tell you what it is. Fortunately, as we've moved forward, some of the newer protocols are using words. Words are great. Yes. Words are really descriptive, right? And so we're starting to see words show up in newer protocols, but SNMP is still very used very widely. So don't be too put off when you see these numbers, and just know that you can take that and you can translate it in a tool like the SNMP mapper.
And again, coming back to what I was saying earlier, for some reason, all of the administratively down, right? So you can see this 20.7, that first one, right, is in this second, or it would be in the first packet. I guess I clicked the second one, but basically, how come we're not seeing this text? It's been converted into, some hex values. Mm-hmm. So what you can do, and this is where the cool thing comes into play, we can click this button, which is to download the PCAP. All right, so it's going to download it. So it's down here. And I've got Wireshark already installed. Again, if you're not familiar with it, you should install it, start playing with it. But because it's already installed, I can just click that PCAP. It's going to open Wireshark. We're going to see that this PCAP is pretty small. I zoomed in maybe a little too far here. I can zoom out just a touch. Okay, so we can see that there's only 2 packets, right? When the interface went down, when it came back up again. And what's really nice, though, at this point is that if I open up this data, we're going to see that, there you go. We can see the text, right? So Wireshark is kindly for us converting that hex information into readable text. So we've got that loopback interface, and it went down. And if I click the second packet, we can get the loopback interface that's come back up again.
Yeah, and the CML is fantastic. Having that packet capture built directly in. There's this lightweight viewer, this packet viewer that we've seen. But with some of these areas where we're doing the full protocol decoding, doing that download, moving into Wireshark can be very, very helpful. So it's a nice, this was a great lab for us to be able to kind of highlight that capability that's in place. So.
And just before I jump onto the router to quickly deploy SNMP version 3, obviously I'm just bringing back up the configuration that we've deployed on the switch. So nothing kind of different there, nothing new, but probably a useful command would be that show SNMP command that I just typed. So I'll go back up a little bit so you can see. So it was just a show SNMP, and it's confirming all the stuff that we just did. So all of this kind of information that we configured about the chassis and the location, it's telling me that it sent out 2 SNMP packets. Well, no kidding. There were 2 traps, and they were actually sent to that 192.168.100.100 address at UDP port 162.
Awesome. All right, before we jump into the V3 piece, I've got a question over here. We can bring Rigo up on the other one as well, but we had a good question from Odak Peter in the chat. How would you set up SNMP to monitor bandwidth usage and raise alerts for interface thresholds? I can't talk today. So I've got some thoughts on this, but how would you answer on this one? If you wanted to use SNMP to monitor bandwidth and then get alerts if an interface gets too hot?
That's a really good question. I was actually looking at some of the OIDs under the Cisco, right? So when I was navigating through it, I went into the Cisco one. and you can drill down to the interface statistics. So stuff like dropped packets or packets per second, or how many bytes in, how many bytes out, what the bandwidth information is, right? So throughput. So you can CRCs and all that kind of stuff. So all of, when you do a show interface on the Cisco router and you've got like a paragraph of stats, you can get that information from the switch through SNMP, or the router through SNMP. And you could also then, if those values are available as a get, you can trap them, right? So if something happens in terms of a threshold, or the example that Hank and I were talking about, like a fan fails, or the power supply, you got multiple power supplies in a switch or router, one of them fails, we can trigger a message at that point that something has happened there. Is that what are you thinking, Hank?
Yeah, I mean, so that's one way to go after. But for this specific question from ODOC, what I've often seen is less trap focused and more kind of the get focused, where your SNMP manager, your NMS, is constantly, maybe every 5 minutes, reaching out with a get message to collect those statistics that you were talking about, Patrick.
Yep.
And then it manages those and it watches them over time. And then on the NMS itself, on that network management server, you configure kind of thresholds and alert thresholds. So sometimes this type of a use case is often going to be less focused on kind of the SNMP configuration on the switch or on the router, and more about like at the NMS solution, the network management server solution, that's collecting the data and saying, hey, if this interface ever gets above 80% and stays that way for 5 minutes, please let me know.
Yes.
Right? Send an email, send a text. Right. Back in the day, a lot of network management systems were actually could tie into phone systems and send pages out. Right. Super showing my age. You could get a page if something went down. So a lot of that comes back to like what you would configure on the actual NMS server itself. So awesome. All right. Well, Rigo, what's our latest question here?
Yeah, so to wrap up our quiz questions for today, we wanted to know, what is the primary purpose of the MIB in SNMP? And it looks like our participants are pretty confident that it's to define the structure of network management data. And I'll hand it over to you guys for the answer.
I think I was showing my age here when I wrote this question, because all I could think of was the classic movie with Will Smith, Men in Black. And so I'm glad someone actually answered my Men in Black plug there in the answer. But no, I think everyone's spot on, I think, with their analysis of what the MIB is in SNMP.
I mean, it totally would have been a solid answer, but you did specify in SNMP.
I know, I had to. I mean, I was like, if I didn't, people would have all answered the blah.
Yeah, Tommy Lee Jones is out there making sure that things are going well. K and J, it's a good answer. I like that. I think what's important, I love the fact that so many of the audience kind of dove in to define the structure of network management data, because this is one of those areas that can be a little confusing. Is the MIB really is just the definition. It's that description. It's a way for vendors that create agents and vendors that create the servers to agree on how this data is going to be represented, right? So it doesn't actually store the configuration. It's not monitoring the traffic. Right. It's a description of how we're going to store this. So we all agree. We know that this value means loopback 0. This value means up. Right.
Okay. With the time we've got left, I'm going to quickly go through the SNMP version 3 demo and config. Don't worry, right? If it's a little quick and you didn't quite catch something, or we didn't explain something enough for you, you've got the guide, right? You can download the YAML file, the packet tracer, and kind of do this on your own at your own pace. But here we go. This is what it basically looks like for version 3, right? I've put in the same access list that we did earlier, right? We're adding that little extra level of security just to kind of protect SNMP and allowing SNMP to just talk to our NMS software. The 3 next commands, though, are the critical ones. And this is where things get a little bit different from version 2 in particular. We don't have a community string with version 3. I've got 3 important concepts or constructs that are going to work together. I'm going to first have to define a user and what parameters that user has. In other words, passwords, for example, for the authentication and encryption. I'm then going to bind that user to a group of users. So for example, I could have a group admin, a group SOC, or a group NOC, or a group management, right? And different users within those groups could have different rights, for example. And then I'm going to bind that group to what we call a view. A view kind of defines and limits which part of the MIB they have access to. So you saw the tree, right, that I was demoing a few minutes ago. It's a huge tree. Maybe I want to limit access to only a certain part of that tree to certain users. So I'm going to create a user. I'm going to attach that user to a group and attach that group to a certain view. I'm going to do those actual commands in the other way, in the reverse order. I'm going to start by defining the view, then the group, and then the user itself. I'm going to paste those because the commands are a little bit long.
Yeah, because so in addition to things like the authentication, the encryption that we talked about with SNMP v3, they also really focused in on this concept of like role-based access control, because you may have different sets of users or different NMS systems that you want access to different parts of the MIB, different parts of data from your switch.
Yeah.
And that's why that view is important. It's a way to collect, okay, this group is allowed access to this portion, right? This other group might get different portions for setup. So
exactly. So what I did is I created a view called SNMP read-only. Again, we're going with that read-only approach. And I went a little crazy just to make it as simple as possible. I've included everything. So ISO, if you remember when I showed you that tree, ISO was at the top. So I've included the entire tree in this view. You wouldn't normally do this in a real production network. You would kind of limit it to what you really want these users to be able to have access to. Then I created a group called admin, and it's a version 3 group, right, for SNMP version 3. And what I've done is I've decided to go full authentication and full encryption as well. So that keyword priv means the full amount of privacy that I can apply. Again, it's a read-only group. I've assigned the view, which is SNMP-RO, and the access list that I created as well. And then that third command was really long. And so what happened is when I pasted it, it kind of shifted over to the left. So what I did is I did an arrow up just so you could see the beginning of the command, and then we can see the rest of the command. So the beginning of the command was that user command, right? And I created a user called user1. It's part of the admin group, which is a version 3 user and group. And then I need to specify what kind of authentication I want and what kind of encryption I want. So for authentication, I could do MD5 or different flavors of SHA. So I went with just SHA-1, basic SHA, and a very original password of Cisco 12345. And then for privacy, I could have done DES or 3DES or something, but I went with AES because that's what you should be using. But I went with the most basic AES, so AES 128. There are a bunch of extra options there. You could go to 192, 256. And then I used a different password just to show you the difference there, Cisco 54321.
I mean, I really applaud your use of high security here, because the addition of 4 and 5 at the end of Cisco 123 is going to throw everybody off. And then by reversing them, right, nobody's going to guess that ever. So these are legit passwords that you've selected. So well done.
Oh my goodness. All right, next 3 commands. Some of them you've seen already. There's just one extra new one here. So the SNMP host command, we saw it a few minutes ago, but we use it for version 2. Here I'm using it for version 3, same IP address, full on privacy for the user 1. Now, this is going to be important in a second because we're going to see that we're going to receive encrypted data in the packet capture in CML, and I'm going to want to decrypt that with Wireshark. So I need a user and I need those 2 passwords. We'll get to that in a second. I'm doing the same traps, right? I'm sticking with what works. We're going to do a shut, no shut on an interface. I'm doing that interface persist for the interface index. And this is where things went a little funky for me this week. So as I was creating this lab, this just wouldn't work. Like I would do all the commands and then I would try to trigger something and I would get no packets, or I would get packets and I wouldn't be able to decrypt them. And I thought, okay, I must have, typed an incorrect password. There's a typo somewhere. And this is where I talked to Joe Clark, who you've been seeing at the beginning of our sessions for the past few weeks. And he helped me figure out that there's a little bug in IOL actually. And what I mean by that is if I try to do the packet capture now, the encryption is not going to work properly. So I know this is going to sound a little strange, but I'm going to do basically a copy run start here or a write mem, and I'm going to reload the router. This is going to go pretty quickly because it's just IOL. Now the good news, and Hank, thanks for making me add a note about this in the guide. You don't need to do this on real gear in your production network. You don't need to do this on Packet Tracer either. It really is just a small bug with the IOL software, if you like. So I know that seems strange, but bear with me. We'll get this sorted out.
Yeah, and we will have to kind of do a bit of a quick one on this. We've got about 5 minutes left here before we've got to be fully done, Patrick. So let's see if we can show everybody the excitement that's in place.
Yeah. So I'm just checking my packet capture. I'm going to start it again. There we go. So my packet capture is running. My router is booting up. enable pass. And I'm going to turn on debug SNMP packets like we did earlier. Okay. I'm getting a ton of messages. Oh, that's the switch.
It's the switch coming up.
Or is it the switch? No, actually, it's not the switch. I'm getting a bunch of messages from the router. Oh, because the interfaces are coming up, of course. Yep. So remember, the traps were link up, link down. I reloaded the router, so all the interfaces are coming up. So cool, I've got a bunch of messages. I don't need to shut the interface. So okay, let's have a look at this capture. I got 4 packets that I received, and right away you can see we've got a small problem, right? You can see in the info part here, it says these packets are encrypted. Let me stop the packet capture. These packets are encrypted, they're authenticated. There's no way that I'm gonna be able to read the PDU or the actual payload in here. So what we can do again is we can very quickly leverage Wireshark to help sort us out. So I'm going to download this PCAP again. There it is. I'm going to open it up in Wireshark. Now, here they are, 4 packets. They're all encrypted. I can't see what these are, but check this out. I'm going to right click one of these SNMP messages. And again, this is all documented in the guide, so don't worry about it. If you're like, how the heck did he do that? It's all in there. So I'm going to go to protocol preferences. I'm going to go to SNMP management protocol, and I'm going to open what's called the users table. And this is where I actually need to put the authentication and encryption information. So we know that I'm going to click add. We know that our user is called user1. We know that I used SHA, really basic SHA-1. And we know that the password was Cisco 12345. Our privacy protocol, we use just regular AES 128. And it's Cisco 54321. Now, what are the demo gods called that we pray to make sure that this all works?
Usually just demo gods, right?
Click OK.
Success.
And it's blue. I'm so glad that it's blue. Let's have a look at this. And I got to scroll all the way down here. This is an SNMP version 2 trap. Here we go. There, yay. We decrypted the SNMP packet successfully. So this is how cool Wireshark is. We can actually give it the SNMP user information and it's password for authentication and encryption, and it will actually decrypt our packet. So this is the interface 00 was going up. That was 01 going up. That was 02 going up. And this was 03 going down because I wasn't using 03. So there we go, folks. Very, very quickly example of using Wireshark in combination with CML in a packet capture.
Yeah. So before we bring Rigo back to kind of close this down, go back to Wireshark real quick, would you?
Yeah, sure.
So one of the things I wanted to point out is I noticed this as it went in. Like we're talking about SNMP v3, we had to do that whole encryption in the user piece, but notice that it's still SNMP v2 trap is what's in there.
Oh yeah, up here.
The focus here is SNMP v3 didn't change the underlying kind of get, set, trap, and form. Like a lot of that is still the same, and it's using that same base. It's the kind of the communication across the network. It's the use of SHA or MD5 and AES for the encryption. That's the portion of the communication that v3 kind of goes into. Once that's done and the communication between the agent and the manager are through, the messages, the data basically is the same, right? So it still comes through as a v2 trap, but we just had to decrypt it so we could see it. And you could even see that in Wireshark where it said encrypted packet and then decrypted packet. So awesome. All right. Any final thoughts here on this one? We're down to the wire, Patrick, here at the end of season 2.
No, listen, again, loads of other show commands that I go through in the guide, like show user, show group, show view, or show SNMP. And then please do have a look at the entire lab, because what we've skipped now today is some really cool features where you actually install the SNMP tools and software on this little server down here and use something called SNMP walk to actually use a get message, right? Because all we've been doing is traps. So I wanted you to get a sense of what a get process would look like. And so towards the end of the lab, I get you to explore that a little bit with a really cool tool called SNMP Walk, where you're going to get information from the router instead of receiving just a trap.
Yeah, it really is a good lab, and great job on this one, Patrick. Yeah, you kind of brought it all for the end. So we'll bring Rigo back. Let us close this down. But there was a couple of questions came in here, and I've got one for you, Patrick, to hit because you're our packet tracer, packet tracer guy. Is there a workaround in packet tracer because some of these commands don't work, right?
Yeah.
Which is not just unique to SNMP. SNMP, but when you've dealt with this, like, what's the best advice we can give to folks that maybe are using Packet Tracer and finding some things aren't exactly the same as what we have kind of in actual gear, or even here in IOL and CML?
I'm a huge fan of Packet Tracer. So I'll just start with that. I started using it when version 1 came out. I think we're up to version 8. I think 9 is coming out soon as well. Don't forget that this piece of software was created primarily for networking academies, where they would also have a rack with some gear. So you're able to actually practice the full commands and all of the features on a real router and a real switch, right? The Packet Tracer was there to allow you to, test some things at home, do some homework and kind of do a deeper dive in certain areas. But yeah, you will encounter some situations where some commands might not be supported, some debug commands or some show commands, or even some of the configuration commands as well. Although for SNMP, it's been, I had a look at it and it looks quite well covered in terms of what's supported. But then hopefully folks will then take advantage of CML free, I guess, Hank, and be able to use that as well to practice.
Yeah, I mean, I think that's the biggest thing, and you've hit it. Packet Tracer is a fantastic tool. I'm a big fan as well. I use it a bunch when I was teaching Netacad, and still go back to it occasionally. But it is a tool for learning the fundamentals of how to do network configuration, network administration. And so just recognize as you're using it, there will be some things that'll be slightly different when you work on real gear. And that's part of, I'll say, the joy of learning how network engineering works. Because we focus in CCNA often on iOS-based devices, but even from Cisco, we've got data center devices with NXOS, we've got service provider devices,
firewalls,
firewalls, all of these other things that are in place. And so just consider Packet Tracer as kind of your place to get started, but it is definitely not exactly what you're going to find on every single piece of hardware from every platform and vendor that's out there.
Yeah, exactly.
Mm-hmm.
I couldn't keep track of chat because I was doing too many things. Did we get some other good questions as well?
There was a couple in there. It was pretty good shape as it went in. I answered a few of them, and then I brought them into the live discussion. There's one that I see in here from Gabriel. How do traps work for hot swappable modules? We actually talked a little bit about this, Patrick and I did before the session. Oftentimes you can configure traps to let you know when hardware fans or power supplies are having problems. And so that's another kind of thing you may want to configure and have your device send a trap when some of those hardware issues set up. But you do generally have to enable those if you want to send traps out. The default behavior with SNMP is not for the device to be super chatty, not running down the hallway to the manager for every single thing that happens, right? You have to specifically tell it what you want to send those traps out for. So
yeah. And the hot swappable stuff, Hank, right, would be in specific slots or ports or modules. So you're able to kind of drill down again in that tree I was showing you, right? So it's like, I don't know, gig, is it module 0, slot 1, interface 3, right? You're able to drill down to specifically what's sitting in that particular slot or port, for example.
Exactly. Awesome. All right. Well, we could probably keep going forever, but I think it's time that we let Rigo kind of close us down and get us prepped for a bit of a summer siesta.
Yeah, I just want to say, thank you both very much for this great session. Another great topic to close out season 2. I hope that everyone found great value in the information and resources that were shared here today, and that it is helpful with your exam studies. But before we fully close it out, just wanted to take a moment to cover a couple of quick items with you all. We do have some prep resources for you at your convenience. We do have a CCNA prep learning map that contains a curated list of learning resources that you will complement your core training and your learning experience. We also have a prep practice quiz with a series of questions that will help test your knowledge about today's topic. And as discussed earlier, we do have some activity files for both Cisco Modeling Labs and Packet Tracer so that you can get some hands-on practice. And of course, we do have the CCNA exam blueprint. This is your main guide to help you prepare for the latest exam topics. So if we do encourage you to access these resources at your convenience by scanning that QR code on your screen, or you can also access the links directly from the Slido resources. And as we've mentioned throughout the session today, sadly, today is the last session for season 2. However, the good news is that we will be back with Hank and Patrick for season 3 at a later date. If you haven't done so already, please do register for the prep program to receive news on the next season whenever that information becomes available. You can go ahead and scan that QR code on the screen to register, or you can also do it directly through the CCNA Prep Hub page. And you can also access that link through the Slido resources as well. Uh, and lastly, we have launched our Slido survey. We would be so grateful if you can just take a moment to complete it and let us know how you like today's presentation. We always look forward to receiving your valuable feedback. And once again, I want to thank Hank and Patrick for this great season. I want to thank all of our attendees for joining us live. And I want to just say, wish you a great day, a great summer, and we hope to see you next time on the Cisco Learning Network and for season 3. I hope you all enjoy the rest of your day. Thank you so much.